Hello children, welcome back to our physics class. So today we are going to learn something very interesting and important topic. That's all about your pressure. So let us begin our class. So before beginning with, let us try to understand what exactly the thrust is. If you consider a body placed on any surface, the weight of the body acts downwards, which indicates that the force exerted by the body on the surface in the downward direction itself is called as your thrust. So thrust is nothing but the weight of the body acting on the surface. So let us try to define exactly what the thrust is. The total force exerted by the body on the surface. I repeat, the total force exerted by the body on the surface itself is called as thrust. For this, let us consider an example. First of all, pressure. Before trying to understand the definition of pressure, let us first define what exactly the thrust is. So what is thrust? So what is thrust? The downward force exerted by the body perpendicular to the surface. I repeat, the downward force exerted by the body perpendicular to the surface is called as thrust whenever the body is placed on the surface. So here we can consider two examples, children. Whenever a body is placed on the surface, the weight of the body acts downwards, perpendicular direction, normal to the surface. Okay, so this downward weight of the body acting on the surface is called as thrust. Similarly, suppose whenever a rocket is launched, then the rocket exerts thrust in the upward direction. There the thrust is acting in the upward direction. Thrust is nothing but force due to that particular body, force acting due to that body on the given surface. Okay, so the force exerted by the body perpendicular to the surface is simply called as your thrust. So for this, let us consider a small example. Consider a body. Let us consider a body of mass, some mass. Which is kept on a surface. Okay, so let us consider that the mass of the body is 2 kg. The mass of the body is 2 kg. So whenever this body is kept on the surface, then it exerts some downward force on this surface. And how much force is it acting? That downward force is nothing but weight of the body given by mg. So as I had told you that mass of the body is 2 kg and g indicates the acceleration due to gravity on the surface of the earth, and its value is taken as 9.8 meter per second square. Hence, the force exerted by the body on the surface in downward direction is given as 2 into 9.8 is given as 19.6 kg meter per second square. Okay, and this kg meter per second square are also written as 19.6 Newton, where 1 Newton itself is nothing but kg meter per second square. Hence, the thrust acting on the surface is taken as 19.6 Newton. I hope you understood the concept. Okay. Well, so the SI unit of thrust, is Newton, whereas the CGS unit of thrust is dyne. Okay. So let me write the same, children. SI unit of thrust Newton. Whereas the CGS unit of thrust dyne. Okay. So this is all about your thrust. So now let us try to understand in detail regarding the pressure. So here we go with pressure. So what is pressure, children? Pressure is a scalar. Even though the thrust is a vector quantity, but pressure is a scalar quantity. So this pressure is defined as the thrust acting on the surface normally, perpendicular thrust acting on the surface. Okay. So thrust acting on the surface, unit area of a surface. So the thrust acting on the surface areas, that means how much thrust is acting and on what area, on how much area. So this is defined as your pressure, or in other words, pressure can also be defined as normal force. Normal means perpendicular force. So perpendicular force acting on unit surface area. Perpendicular force acting on unit surface area itself is called as your thrust. So thrust, as I already told you, thrust is nothing but the weight of the body acting perpendicularly. The perpendicular force acting downwards on the surface area is called as a thrust. Here perpendicular is included in the thrust. In other words, force, what type of force? The perpendicular force, normal force or perpendicular force. So both names. This normal force here itself is called as thrust. So that means that perpendicular force, in other name it is also called as weight of the body acting downwards on a given surface area is called as your pressure. So in mathematically this is given as pressure P is equals to force upon area. What type of force? Only perpendicular force, normal force. Normal force acting per unit area is called as your pressure. And remember that it's a particular direction, that is only a downward direction, that normal direction. Hence it is a scalar quantity. Always remember, pressure is a scalar quantity. It is a scalar quantity. Pressure is a scalar quantity. And moving to the SI units. SI units of pressure is, so force is generally measured in Newton and area is measured in meter square. So SI units of pressure is Newton meter square or simply Pascal. So SI units of pressure is Newton per meter square or Pascal. Similarly, pressure also have other units, where other units of pressure, if you see, bar, where 1 bar is equals to 10 power 5 pascals. What is that? Where 1 bar is equals to 10 power 5 pascals. Is that okay, children? So 1 bar is equals to 10 power 5 Pascal. And remember that Pascal. Who is Pascal? Pascal is the name of a scientist named Blaise Pascal. Okay. In honor of Blaise Pascal. So as a respect, as a token of respect, in honor of Blaise Pascal, the units of pressure is taken as your Pascal. Okay. And symbolically it is written as capital P small a. And if you want to convert, bar is an other unit of this pressure, where 1 bar is equals to 10 power 5 Pascal. Also you have one more unit of pressure, and this is also at 1 atm. Okay, bar and atm. Atm full form is atmosphere. Okay, so these are the different units of pressure. Got it, children? Well, so now let us try to understand in detail regarding the pressure acted by a body in different conditions. So this, as I told you, pressure is equals to force by area, or pressure can also be taken as, this is nothing but in detail, pressure is equals to normal force upon area, or pressure is also equals to thrust upon area. When thrust and area are given, pressure equals to thrust upon area. When force and area is given, pressure equals to that force upon area you can consider. And remember, pressure is a scalar quantity, but thrust is a type of force and it is considered as a vector quantity. Okay, children. So now let us consider few applications of pressure. For example, if you consider a horse, a donkey and a camel, and all the three are allowed to walk on a desert area, then among the three, that is a horse, a donkey and a camel, which one exerts more pressure on the sand? So here you have to remember that as pressure is defined as force upon area, if force is greater, so this one let me explain you clearly. So since pressure is equals to force upon area, for a given surface, if area of surface is constant, if area being same, if force is increased, then pressure will be increased. This indicates that pressure is directly proportional to force. That means pressure, the amount of pressure increases with increase in force, provided area of cross section remains same. Okay, so pressure as force increases, keeping the area constant, as force increases, we observe that pressure also increases, since pressure is directly proportional to force. Hence, as force increases, pressure also increases. So pressure increases with increase in force, provided area of surface cross section remains same. Similarly, the second case, okay, for the same case, if force remains constant, if force remains constant and area increases, as pressure is inversely proportional to area, earlier we observed that pressure is directly proportional to force if area remains constant. And similarly, pressure is inversely proportional to area if force remains constant. Isn't it? So, as area increases, the value of pressure decreases. With increase in area, the amount of pressure acting on the surface decreases. Why? Because they both are inversely proportional to each other. And lesser the area of cross section, larger will be pressure. Larger the area of cross section, lesser will be pressure. So, let me write the same. So, when is this possible? Provided the force remains constant. Okay. So, this thing you need to remember, children. Now, let us come to our example. So, what I have told you that we were provided with 3 animals. One is horse, other is donkey, and the third one is camel. Okay. So, which one exerts larger pressure on the sand? So, very clearly we know that the surface area of foot of a camel, for a camel, if you observe the foot, the legs, okay, the foot of the camel, it covers a larger surface area. Whenever it covers a larger surface area, it exerts less pressure. Whereas, if you observe the foot of a donkey or a horse, it has small cross-sectional areas. So, for small cross-section areas, the pressure exerted on the surface will be larger. So, among the 3, horse, donkey and a camel, which one exerts less pressure? Camel exerts less pressure, whereas horse and donkey can exert larger pressure. Similarly, children, did you ever observe that heavy trucks are provided with more number of wheels? Okay, so what is the reason? So, heavy trucks and all, if it is carrying some goods and all. So, instead of a 4-wheel, they are provided with some 8-wheel or 10 wheels and so on. What is the reason behind that? So, number of wheels means the number of contacting area increases. Single wire if you consider, single tire if you consider, it hardly have particular surface area and contact. 2 tires means double amount of surface area. 4 tires means 4 times of the surface area. Now they are using 8 wheels. So, 8 wheels indicates that it covers large surface area in contact. When area of contact is more, whenever area of contact is more, the pressure exerted by that truck on the road will be less. So, in order to decrease the pressure on the road, they are extending the number of wheels to increase the surface area. Not only this, children. So, whenever you observe that cold surface area like snow areas and all, skiers, you know skiers, the people who travel on the snow, okay, skiers, they use skis to go on the snow and all. So, they are not provided with any wheels. So, what do you observe means those skies. So, the people who run these skies are called as skiers, and that machine itself is called as your skies. Okay, so they will be moving on that sky. These people will be standing on the skies and they will be moving on that snow. Okay, so if you observe the bottom of the skies, if you people by on foot, you are not able to easily move on the snow. Why? Because your foot has a smaller area of cross section. But skies, if you consider, the skies will be wider and will be little larger. So as a result, these skies covers a large surface area in contact with the snow. So because of large surface in contact with the snow, it exerts less pressure and the person can be carried easily. The reason why these skies are never provided with the sledges and skies never provided with wheels. Okay, so because it has a widened surface and the larger length, so less pressure will be, because of increase in the area of contact, pressure will be reduced. Okay, do you ever observe the knives are often sharpened whenever you want to cut the vegetables or any items? What is the reason behind? So if you sharpen the knives, the area of contact, the area will be reduced. Sharpening the bottom area means the area of contact will be reduced. So whenever the area of contact is reduced, it can easily penetrate inside that body, whatever you want to cut. So in order to have a large penetrating power, the materials are sharpened so that it can easily enter the given object. If you even observe a flattened needle or a sharpened needle, so in order to insert this, which needle will go insert easily? Obviously sharpened needles. The reason behind that, less surface. Sharp needle has less surface area in contact, hence it can get immersed easily or penetrates easily, whereas that flat needle cannot get inside easily. And one more example, children, if you would have considered a large building, the foundations of very tall, high buildings are made vast. Did you ever observe the foundation of the tallest buildings? It will be made widened. What is the reason behind it? Because of the widened surface area in contact, pressure exerted by the tall building on the ground will be reduced and it will not be inside the ground because of its own weight. So to reduce the pressure of that tall buildings on the ground, their foundations are made wider. So this is all the applications of the pressure, children. So based on this concept, let us try to solve few numericals accordingly. Okay.